everyone, this is just a quick little video on factorising review. So the basic thing to remember with factorising is first to look for the highest common factors. So if we look at this first example, we've got quite a few factors that are common going on. So within the numbers, we've got some factors that are common. The highest common factor in the number is a 4. So we take that out or divide through by that. And then if we look at the x's, they're both common. The way to remember which is most common is the highest common factor is always the lowest power. So the lowest power in this case is a power of 1. And then we have the y's. So we've got a power of 1 and power of 3. So then we have, that means the highest common factor is also a power of 1. Of course you don't need to write the powers of 1, but it can be good just to jog your memory. Then all we have to do is fill in the factors that are left over. So if you to look at the first term here, you've got 20 divided by 4, that leaves a factor of 5. X squared divided by x, that leaves a factor of x. And y divided by y, we don't need any more y's. Then we have a look at the second term, this term here. 16 divided by 4 is 4, so there was a factor of 4 left over. X divided by x, we don't need any more x's. And y cubed divided by y is y squared. So that's so on the inside is the factors that are left over, and on the outside are the highest common factors. This second example is an example where we're going to factorize by grouping into pairs. So we've got two pairs here, and we're going to have a look at grouping both, factorising both of them by looking at their highest common factors. So the first pair, the highest common factor is x squared, and then we have a look at the factors that are left over. In the first term it's an x, and in the second term it's a 4. Then we have a look at the second lot of pairs. The negative is common, so I'm going to take that out, and the 3 is common. And then we have a look at the factors that are left over. I've taken out the negative, so I don't need that anymore. I've taken out the 3, so I don't need that anymore. So that means I'm left over with a factor of x. If we look at the second term, we've already got the negative. Now with the 12, if we've divided through by the 3, that means we've got a factor of 4 left over. Now, if we've taken out the negative, that means we're left with a positive here. Now this won't always happen, but when we're factorising by grouping into pairs, you've got to check whether or not you get left with any common factors. We've actually got common factors there as well. It's like saying x squared times by a minus 3a. The a is common, and so in this case the bracket is common. So the bracket is a common factor. We can put that out the front. And in the second bracket we can put the factors that are left over, the factors that when we've divided through we've got left with. So there we go. Now we're going to have a look at these examples down the bottom here. These are all examples of difference of two squares or dots. Now remember from the expanding video, if you've got two brackets that have exactly the same terms except one has a minus and one has a positive, when you expand that you get the first term squared minus the second term squared. So we're now working the other way. We're starting off with the expanded form, we're trying to put it back into brackets. So we're looking for squares. I'm going to do some thinking steps as I go here. As you get more confident at this, you can leave some of these out. So if we have a look at this first one, this first term is like 3x all squared, and 25, we can see that's 5 squared. So we have a square minus a square. So we go first term, second term, one gets a plus and one gets a minus. Now if we have a look at this next example, that first term, that's not a square term. I'm going to come down and complete it down here. It's not a square term, so we have to think about if there's something else we can do to it. If you have a look, 48 and 3 actually have a common factor. We can take the common factor of 3 out first. So if I put that out the front to start with, I'm left with x squared minus 16. Now 16 is a square, so we have a square minus a square. The 3 has to stay out the front. We can't do anything with that. So we have a square minus a square. So we go first term, second term, one gets a plus and one gets a minus. The reason it's now 4 is because 16 is 4 squared. So the second term is actually 4. Okay. The third example of difference of two squares, if we've got x squared minus 5, I can't actually see a square there. So I'm going to have to manipulate the situation. I'm going to manipulate it by writing a square. And how do I turn that 5 into a square? If I square root it and then square it again, I'm left with my original 5. So now we have a square minus a square. So once again, same rule. First term, second term. One gets a plus and one gets a minus. Now the last example of difference of two squares is we've got a square factor there, and if we're going to have to rewrite this second term so that it looks like a square as well. So I'm just going to take one extra step to rewrite that as a square, and now we have a square minus a square. First term goes in, so that's x minus 2. X minus 2. Second term goes in. One gets a plus, one gets a minus. The important thing when you're doing those types of examples is that you always check for common factors. In this case, there are none, so we can't simplify it any further. Now, the last three examples are all examples of quadratic factorization. The first three are monic quadratic factorization. So remember, with the quadratics, they come in the form ax squared plus bx plus c. Monics are where the a is equal to 1. Now remember, when we're looking at factorizing these, we're going to do it by splitting the middle term. We're looking for the two numbers that add to give b and multiply to give c. So in the first one, we're looking for two numbers to multiply to give 6 and add to give 5. That's 2 times by 3. I'll do the first example with all the steps, and from then on we can skip the steps. So what we do is we split the middle term, so the 5 turns into 2x and 3x, and then we just group in the pairs. So we factorize by grouping into pairs. X plus 2 plus 3, x plus 2, and then the brackets are common, x plus 2, x plus 3. And if you have a look, the numbers that we have in the brackets are the two numbers that we started with. So we can actually just skip the steps. But remember, we're actually getting this from splitting the middle term. Okay, let's have a look at the second example. Two numbers that add to give b and multiply to give c. So two numbers that are multiplying to give negative 14 and adding to give negative 5. The hint is, if you're multiplying to give a negative, that means you must have one number that's a positive and one number that's a negative. So negative 7 times by positive 2, that equals negative 14 when multiplied. And if I add those two numbers together, they equal negative 5. So they're my two numbers. So I go bracket, bracket, x in first, and then just one number at a time, negative 7 plus 2. It doesn't matter the order you put them in. This third example is actually a monic as well. However, it's what we might call a cheeky monic, because there's a common factor in there that's making it look like it isn't a monic, but it is actually a monic once we factorize that out. So it has a common factor of 3. If I factorize that out, I get left with x squared minus 9x plus 20. So we're looking for two numbers that add to give b and multiply to give c. So multiply to give 20 and add to give negative 9. I'm thinking negative 4 times by negative 5. So the 3 has to stay out the front because I've factorized it out already. It can't go anywhere else. And then we're going to have x minus 4, x minus 5. Okay, now the very last example we have here is a non-monic. So in non-monics, we're adding to give b, but multiplying to give ac. And in this example, we can't skip the steps. We must show all of the steps splitting the middle term. So we're looking for two numbers that multiply to give 3 times by 4, which is 12, and two numbers that add to give negative 8. So I'm thinking negative 6 times negative 2. That will equal positive 12, and that will add to negative 8. So we split the middle term. So we get 3x squared minus 6x minus 2x plus 4. And then we factorize by grouping into pairs. 3x, x minus 2. Now I'm going to factorize the negative out as well here. So that leaves us with an x. Now the trick here is if I divide a positive by a negative, that leaves a negative here. And then the 4 divided by the 2 is 2. And if we have a look, the brackets are the same. So we factorize those matching brackets, and then we get left with 3x minus 2. I hope that helps, guys, with review of factorization. If you need any help, just sing out. Thanks, guys.